So I wanted to go through a couple of ester naming and structure writing examples so you can kind of see how this actually works. Remember, when we're dealing with an ester, we have carbon, hydrogen, oxygen, and we have that break in the carbon chain. C double bond O, single bond O, and we see a break in that carbon chain. Remember, these are slightly polar, but not water soluble. These kind of have the most different way of naming as opposed to some of the other organic molecules that we've talked about. We're going to use an anoate ending. Some of the physical properties, these actually smell kind of nice. Those fruity, pleasant, and perfumey odors are often from the esters that are in those particular things. So for esters end up getting made from an alcohol and a carboxylic acid. So the name comes from those pieces that we're going to see in an example. The alcohol piece gets named as a branch, which means you're going to use that YL ending. And the carboxylic acid piece gets named as the main root. So what we're going to be looking for an ester is how to break the ester into the two pieces, or how to see the two pieces of an ester, because that's going to be very important for how these actually get named. So we want to see this with an example. So here we're dealing with an ester. We recognize that we're dealing with an ester because we see the C double bond O, single bond O, that disruption in the carbon chain. Now, what we want to do is every time you are looking at an ester, when you first look at an ester, what you want to do is you want to figure out which pieces, where are the pieces for that molecule? What is that carboxylic acid side? What is that alcohol side? And the bond you're always going to look at is this bond that I'm putting kind of on the dashed red line here. It's always going to be this bond between the carbon and the single bond oxygen. That's going to divide the molecule into the two parts. Remember, we're looking to find a carboxylic acid piece and an alcohol piece. Well, you can kind of see the pieces now that we've kind of split the molecule at this point. The side with the C double bond O is going to be that carboxylic acid piece of the molecule. Then the part that has the oxygen, so on the left-hand side in this case, that's going to be the alcohol. So you're always looking at this key bond between the carbon and the oxygen. That's what's going to split the ester into its two pieces of the carboxylic acid side and the alcohol side of the molecule. And we use that for our naming. So in order to name this ester, what are we looking at for the name? Well, it's an ester, so we're going to get that anoate ending in there. We're going to get our anoate ending in for that ester. Now, the part that goes with the ending, the main root, is going to come from the carboxylic acid side. So we're looking at the carboxylic acid side of the molecule, and we're counting how many carbons we have. So we have 1, 2, 3, 4, 5 carbons on that carboxylic acid side. The prefix for 5 is pent. So we're going to get that in. Then the alcohol end of the molecule gets named as if it were a branch. So that alcohol end of the molecule has 2 carbons in it. A 2-carbon branch is an ethyl branch. So we're going to get that out in front. So the name of this molecule is going to be ethyl pentanoate. The carboxylic acid side, kind of in red, that's what's going to supply the main root of the name. And then the alcohol piece in blue is what's going to be named out front as if it were a branch. Remember, the key thing whenever you are looking at An ester is you have to look at this bond here in purple. It's always the one between the carbon and the oxygen that's going to split that ester into its two component pieces that you then want to identify how many carbons on each side and then be able to correctly name that. If we do one going the opposite way, starting with a name and writing out what that structure is, we can do that for methyl propanoate. So we recognize we're dealing with an ester from the anoate ending that we see at the end. So if we're dealing with an ester, I suggest writing out that ester functional group. So if I write out that ester functional group, it doesn't matter which side. Remember, we can kind of put the oxygen on either side. Here's my ester functional group. And when we're looking at that ester functional group, we already have the bonds in place that we kind of need to look at to split the molecule into its two different sides. Remember, the key bond is between the C double bond O and the C single bond O. It's this bond right here. I'm kind of cutting across with that dashed red line. That's going to set up the two sides of the molecule. The side with the C double bond O, remember this is going to be our carboxylic acid side of the molecule. The side with the oxygen is going to be our alcohol side of the molecule. So now we kind of take the pieces of the name and do what we need to with that for the structure. Well, the carboxylic acid side of the molecule, that's what goes with the ending. So the ending is OH, so the main root here is prop. But the main root being prop, that tells you that the carboxylic acid side of the molecule will have 3 carbons. Now here's where you have to be careful. I don't want to add in 3 additional carbons. I already have 1 carbon in place on that carboxylic acid side. So I don't need 3 additional ones. I need 3 total. So I'm going to get 2 more carbons in here. Now I have 3 total carbons on that carboxylic acid side of the molecule, matching that prop. Now for the alcohol side of the molecule, remember that gets named as a branch out front. So in blue here I see methyl. Well, methyl tells me that I'm dealing with 1 carbon. So on the alcohol side of the molecule, in this case it's the right-hand side of the molecule, I'm going to get 1 carbon. Now I have the main skeletal structure. I have the backbone. I have the framework set up. The last piece of this is to fill in the proper number of hydrogens. So again, we're looking at 4 bonds to carbon, 2 bonds to oxygen. So that means the carbon all the way on the left. Get up to 4 bonds, I'll need 3 hydrogens. The next carbon over, 2 bonds, 2 hydrogens. The carbon with the C double bond O already has 4 bonds. We're going to leave that alone. The oxygen that's double bonded to the carbon already has its 2 bonds. We're going to leave that alone. The oxygen to the right of the carbon has its 2 bonds. We're going to leave that alone. That already has its proper number of bonds. Now the carbon all the way on the right has 1 bond. We got to get up to 4. So that's going to make 3 hydrogens that we need to add into this one. So here we have our structure of methyl propanoate. Again, for an ester, you really have to visualize the different pieces of the molecule and then match them up correctly with the name. There's one last one I want to do. It's not an ester, but it's an example that there's kind of an error on the slide when we did it in class. So I want to make sure we're okay doing this. This ends up being an amine. We recognize it's an amine from the nitrogen that's there in the molecule. So For an amine, we're going to start with the amine ending. That's just amine as a separate word. And now we kind of name the groups that are hanging off. So if we look at the groups that are hanging off, on the left-hand side, I have CH2, CH3. That's 2 carbons. That would be an ethyl group. On the right-hand side, I have 3 carbons. That would be a propyl group. And down below, I have a 1 carbon group. That would be a methyl group. Well, when I have all of these different groups, remember, I have to list them alphabetically. So I have an ethyl group, a methyl group, and a propyl group. I need to write those out alphabetically in order to describe them. So E is going to be first, so that's going to be the ethyl. So we're going to have ethyl, then methyl, and then finally propylamine. Now remember, these all get alphabetized, and that's the order that you're going to appear them in. E comes first between all these, then the M, then the P.